The next topic is differentiation of determinants. Here, determinant is given to you, that is f of 1x, f of 2x, g1x and g2x. Now, if we open this determinant, we'll get f1x, g2x minus f2x, g1x. Now, if we want to differentiate, that is delta dash x is equal to, we'll differentiate for these two also, right? So it's nothing but d by dx of f1x g2x minus d by dx of f2x g1x. Now you know already d by dx of uv, that is a product rule, is nothing but u times of dv dx plus v times of du by dx. So similarly, apply over here. f1x, differentiate of g2x is nothing but g2 dash x plus g2x into f1 dash x. Similarly, minus f2x g1 dash x minus into plus minus g1x f2 dash x. So now just combine the thing, like so if we combine this and this, we can write it as f1 dash x g2x minus f2 dash x g1 x, and combine the remaining two, that is plus f1 x g2 dash x minus f2 x g1 dash x. So now if you observe, this is the determinant of some, this is a determinant, right? How can we write in terms of a determinant format is, here if you observe, f1 dash and f2 dash will be the rows over here, and g2x g1x will be the columns. So it will be like this, g1x g2x. You can also verify it, that is by taking the reverse of this. When you take the determinant, it's the cross multiplication. So f1 dash into g2x minus f2 dash into g1x. Similarly, here f1x and f2x will be the rows, and the remaining will be the columns. You can also verify by doing the cross multiplication. So finally, you can write the differentiate of a determinant in terms of summation of two different determinants. If you observe, there are only two rows and two columns. It's of order 2. So when you do the differentiation, after differentiation, you will get the summation of two different determinants of order 2 itself. If you have order 3 over here, then you're gonna get in the result as summation of three different determinants of order 3 each. So let's solve a question. In this question, a determinant of f of x is given to you, and it is told that p is a constant, and we need to find the third differentiation of f of x when x is equal to 0. So just now we have seen the differentiation of determinants concept. So basically here, if we do the first time derivative, that is the or d by dx of f of x is nothing but first do the differentiation of first row and the remaining two rows will be the as it is. So if you do the differentiation of x cube, it is 3x square. Sin x ka differentiation, it is cos x. And cos x ka differentiation minus sin x. And remaining two rows remain as it is. And plus, now you need to do the differentiation of second row. First row and third row will remain as it is. So first row remain as it is. Second row ka differentiation all are constant, so it becomes 0, 0, 0. Similarly, now keep first row and second row as it is. Do third row differentiation. Again, p is a constant, so again it will be 0, 0, 0. So again, this is the property. If any row or column is 0, then the determinant gonna be 0. So this determinant is 0. This is determinant is also 0. Now we need to calculate the double differentiation of f of x. So from here only we'll consider it. Now we need to consider this determinant. So differentiate the first row and remaining two rows will remain as it is. So it's nothing but 6x cos x ka differentiation minus sin x ka differentiation cos x. And remaining two rows will remain as it is. And again, if you do the differentiation for this, again first row will and third row will remain as it is. Again second row are constant, so it becomes 0. Again third row is constant, it becomes 0. Now do the triple derivation. From here, from this determinant, differentiate the first row. It will be 6 minus cos x, minus into minus, plus that is sin x, 6 minus 1, 0, p square and p cube. And the remaining will be the 0 as second and third row are constants. Now we need to calculate this value, that is when x is equal to 0. So cos 0 is minus 1, cos 0 is 1, but already minus is present, so it is minus 1, sin 0, 0, and second and third row remain as it is because they don't have any kind of x variable. So again a determinant property should be used. Any two rows or any two columns are same, then the determinant gonna be 0. Here first and second row elements are same, so the final answer gonna be 0, and according to the option D is the correct because it is independent of